Hello and welcome to Focus IR. I'm John Hewman, and today joining us from the laboratory is Sarah Greenhalgh, who is the Managing Director and co-founder of Kerato, which is one of the companies within a portfolio of very exciting innovators within BSF Enterprise, a world-leading developer of industrial tissue engineering. Welcome, Sarah.
Thank you very much. Nice to be here, John.
No, great to have you. Now, BSF has many applications. I think it's best known for lab-grown leather and lab-grown meat. But Kerato does something different, and you've been involved in Kerato from the very beginning, which is corneas. So perhaps, first of all, tell us a bit about yourself and your background, how you came to found Kerato, and how you've ended up within the family of BSF companies.
I started my career, or the main bit of it, at Newcastle University, where I was working with academics to get funding applications in, and then manage their funding once they had them, so managing big interdisciplinary research projects. I moved into the medical school, where I was designing and running clinical trials to support a very early phase academic discoveries and getting them into the patients that need them most. And I was running a couple of big institutional medical research council grants that helped academics to translate their research and, again, to sort of make the next steps into making them commercial entities that, again, mean that they can get to the patients that need them most. I moved into SMEs about 5 years ago, and since then I've been working with early stage companies to help them really take those sort of those really good ideas and then help them get to the people that need them, help them to translate their academic discoveries into commercial entities.
Yeah, excellent. Let's talk about that. Let's drill down into what that actually means. So tell us a bit more about Kerato itself. You know, at a high level, we know it's working in the space, the corneal space. But what does it do? What's the problem it's addressing? Why is this such a potentially exciting technology?
So our first product is a biosynthetic cornea. So this is addressing, there are estimated to be around 13 million people worldwide with corneal blindness. The problem that we're addressing is the fact that there are all these people that could benefit from a corneal transplant, but the difficulty is that 55% of the world's population don't have access to good donor corneal tissue. This is for many reasons. So in the West, we're quite lucky. We have a lot of donor corneas that are available for implantation, but there are lots of areas of the world where this is a major problem, and the sort of the normal routes of having people donate their corneas upon death aren't really feasible in some of these in some cultures, for instance. So what we have is we've developed a medical device called the LiQD Cornea. So it is a single-handed, single injection that you inject into damaged cornea tissue, and it helps the eye to heal itself. So it re-epithelializes the surface of the cornea, meaning that within a few days it's starting to work, and within 6 months you have complete re-epithelialization of the eye, of the cornea.
So it's a regenerative therapy rather than a transplant? Exactly.
So the actual effect is the same. So it's the same effect as a corneal transplant, but what it does is it helps the cornea to regenerate itself. So you end up with your own tissue that's repaired itself. And so it can get over really exciting things. So the physiology of eyes between different races, for instance, can be different. So because this is an injectable sort of gel-like cornea that you inject in, it doesn't matter if it doesn't matter where the donor tissue comes from, because it will just interact with the surface tissue the same as the tissue itself. So you get over some of those physiological problems that you would have between donors. And because of the way it's created, it doesn't there's no immune response, so your chance of graft rejection is reduced compared with a sort of standard cornea transplants as well.
Yeah, that was actually going to be my next question. Presumably, you know, as not just this isn't just an alternative to transplants. It potentially could be better. That there are, you know, significant advances in terms of outcomes that come with this technology potentially.
I think that's what's really interesting about it, actually. So to do a cornea transplant, you obviously need the donor tissue, you need all the sort of everything to align at the right time. It's quite a complex inpatient procedure that has quite a complex follow-up afterwards. So because our solution is a single injection, it's much easier. So it should mean that you can schedule it. You don't need to wait for the donor cornea to come along, so you can schedule it at a time that suits the patient and the clinical team, obviously, but very much at a time that suits the patient. Because you're not waiting for the donor tissue, you don't have any of the stress around, is it going to be available? Am I going to be able to do it? So you can just go in, and it should be a very straightforward inpatient procedure. That means that the follow-up is much more straightforward as well. The risk of graft rejection is lower. And so the sort of follow-up procedures and any kind of follow-up complications are going to be reduced. And we think that it should lead to much shorter inpatient time as well. You should just be able to do it in day surgery, and then with sort of some careful, sort of at-home follow-up, you should just be able to, go back to your normal life much quicker than sort of standard corneal transplants that are a much more complicated procedure.
Yeah, and I guess this would come with significant cost advantages as well, which is obviously the thing that health service planners want to hear.
Exactly. So in terms of the actual cost of the injection versus a cornea, that's going to be a lot cheaper. So for actually acquiring the cornea for transplant, our device is going to be a cheaper solution. Also, all of the kind of surrounding and infrastructure costs, inpatient time is reduced, clinician time is reduced, follow-up time is reduced. So all of the different factors that contribute to how much the procedure costs will be reduced. So overall, it should be saving health services considerable amounts of money.
Yeah, brilliant stuff. Let's talk about the sort of patent protection behind this size. Presumably, it's well protected both in terms of patents and know-how.
Exactly. So we have patents for the actual device itself. So in terms of the formulation and the syringe are both protected. So the administration device and the formulation that goes into the syringe are both protected. There's all the know-how associated with and the background knowledge that has gone into the development of the product that makes it quite unique. And then within Kerato, we have complementary patents around the kind of tissue engineering side. So the way that both the formulation itself is created, but also the way that the formulation, when injected into the cornea, the way that it reacts with the body's own tissue. So it's a really nice, neat set of IP that we have that kind of works really well within the company.
Yeah, brilliant. I guess the big question is when can we expect to see this in use? What sort of progress have you made so far in terms of the development? And then, of course, where your expertise really comes in, how are you getting on in terms of taking this to a commercial product?
So in terms of the development of the product, we completed preclinical studies this summer. So we were able to prove that within a few days post-administration, the corneal cells had started to heal themselves. And within 6 months, we found that the reepithelialization or the surface of the cornea had been completely reconstructed as a result of the intervention. So that was really exciting. We have a bit of work around sort of some of the additional biocompatibility and biosensitivity testing that we need to do before we can go into patients. We're actually quite excited about this product because we think it will have benefits both in the human markets, which I've already explained, but also in animal markets. So particularly in brachy-breeds dogs, which are the ones with the squash noses that are quite inclined to corneal damage because they just walk into things because their nose isn't there to protect them. There's quite an unmet need in that veterinary market for a really good solution that will help these dogs that are currently sort of having to, receive a drop every 4 hours for 4 weeks to try and repair their damage. So this has quite good implications in veterinary markets, and we're hoping to commence veterinary trials early 2025, and hoping to have the product on the market by the end of next year within veterinary circles so that vets can start getting this into their patients that need the treatment. In terms of human clinical trials, we're going to spend the next sort of 8 months to 12 months, really working with clinicians, working with patient groups to get our clinical trials really designed to suit everybody, to make sure that the device will fit really neatly into clinical pathways. And then we're hoping to submit for ethical approval for clinical trials and commence very early in 2026, the timeline that we're working to at the moment, with a view to getting the product onto the market in 2028.
So, the animals come first, and it was as it was always the case in Britain.
Sadly, it's a slightly easier market to access. There are slightly less regulatory hurdles because obviously humans are very, as rightly, very tightly controlled. We need to generate a lot of clinical evidence. We need to generate a lot of safety and efficacy evidence to support regulatory approvals. So we're working on that in the background whilst we advance this in veterinary so that we can, start getting it into patients and actually start making a difference, which is really exciting.
Yeah, absolutely. I presume, you mentioned, in terms of the design of the trials that you're working with clinicians, presumably that they can see the benefits of this technology. There must be some excitement out there as well.
Exactly, and their early thoughts have already fed into the way that we've designed the product. So feedback from all the people that we've spoken to is that they want it to be single-handed administration. They don't want to be complicated. So the idea that a clinician could, almost do it on their own, I guess, is something that for me is really exciting. So obviously we will be going into specialist clinics initially, but the sort of broader, longer-term vision is that this could be a really easy-to-use solution where you don't necessarily need... You would obviously need a sort of clinical clean setting, but it could be that the product could be used in more rural locations or third world locations or places where they don't have access to a full, operating theatre and clinical infrastructure because of the easy to administer nature and the fact that you can do it single-handedly. I would like to hope it could have a massive impact on sort of patient lives and, patient outcomes sort of in sort of much broader applications and the sort of, the West where we're initially focusing our trials.
Yeah, it makes a lot of sense. It sounds like a very, very important, potentially life-changing technology, as you say, for many, many people. Sarah, it's been an absolute pleasure talking to you, and I wish you the very best of luck as you pursue commercial success for this fantastic technology.